Hi, Dean. We're ready for section 7.2, sum and difference identities. So there's going to be some formulas that you're going to need to remember. The first one is the sum and difference identity for cosine. So that means if we are taking the cosine of, say, angle alpha plus or minus angle beta, so it works for sum or difference, that is going to equal the cosine of the first angle alpha times the cosine of the second angle beta, and whatever your first operation is, plus or minus, this is going to be the opposite, minus or plus. So feel free to write yourself a note. This is going to be the opposite sign. And then we'll have sine of the first angle alpha times the sine of the second angle beta. Okay, so this is the sum and difference identity formula for cosine. So that comes in handy with problems like example 1, where we're asked to find the exact value of an expression, but the angle is not one that we're familiar with. So remember, the angles that we are familiar with are all of the quadrantal angles, 0, 90, 180, but also 30 degrees, which is any multiple of pi over 6, all 45 degrees, pi over 4, and 60 degrees, which is pi over 3. So your goal is to rewrite any of those unrecognized angles as a sum or difference of one of the angles that we do know. So let's try the first one. Cosine of negative 15 degrees, we can write as the cosine of 30 degrees minus 45 degrees, two angles that we're familiar with, and then plug it into our formula. So that would be the cosine of 30 degrees times the cosine of 45 degrees plus, remember we changed the sign, the sine of 30 degrees times the sine of 45 degrees. And we know all of those values. Cosine of 30 degrees is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Plus sine of 30 degrees is 1/2. And the sine of 45 degrees is square root of 2 over 2. So that gives us the square root of 6 over 4 plus the square root of 2 over 4. And you can leave it like that. But since we have common denominators, we can write it as the square root of 6 plus the square root of 2 all over 4. Remember, we cannot combine square roots unless they are identical radicands. So for the second one, cosine of 19 pi over 12, that's a little tougher because we don't know any of our radians with a denominator of 12. Notice of the ones that we do know, all of those denominators divide evenly into 12. So we want to write that 19 twelfths as an addition of numbers that would reduce that 12. So one example would be, we could take the cosine and write that 19 as 3 plus 16. So we can have 3 pi over 12 plus 16 pi over 12. And all of those numbers will reduce the 12. So 3 goes into 12 4 times. So we get the cosine of pi over 4 plus, and 16 and 12 both have 4 in common. So we can reduce that to 4 pi over 3. Now using our sum identity, we can rewrite that as the cosine of pi over 4 times the cosine of 4 pi over 3 minus, don't forget to change your sign, the sine of pi over 4 times the sine of 4 pi over 3. So the cosine of pi over 4 is the square root of 2 over 2. 4 pi over 3 is in the third quadrant, so the cosine would be a negative 1/2 minus the sine of pi over 4 is square root of 2 over 2. And again, being in the third quadrant, the sine of 4 pi over 3 would be a negative square root of 3 over 2. So when we multiply these out, we get a negative square root of 2 over 4 plus the square root of 6 over 4, which we can combine as a negative square root of 2 plus the square root of 6 over 4. Now the sum and difference identity for sine, if we had the sine of an angle alpha plus or minus an angle beta, is a little bit different. Okay, sine is nicer. It lets cosine play along in the first round. So we would end up getting sine of the first angle alpha times the cosine of the second angle beta. And then the sign stays the same. If you start with addition, you keep addition. If you start with subtraction, you keep subtraction. And then the angles switch. We do cosine of the first angle alpha times sine of the second angle beta. So you might want to highlight that one. And now we want to do the sum and difference identity for a tangent. So tangent of alpha plus or minus beta equals tangent of the first angle. We keep the sign on top, plus or minus the tangent of the second angle beta. This is going to be a fraction. All of that is divided by 1, and then we change the signs. So minus plus tangent of the first angle alpha times tangent of the second angle beta. So again, this means opposite sign, and this means same sign. So let's do a couple of examples using the sum and difference of the sine and of the tangent. So in part A, we have the sine of 13 pi over 12. 12 is not one of the denominators we know, so we're going to split 13 up as a sum of two numbers that will divide into 12. So we can use the sine of 3 pi over 12 plus 10 pi over 12. Both of these will reduce. It will give us the sine of pi over 4 plus 5 pi over 6. Both of these radians we are familiar with. So now let's write it into our sum identity. We would take the sine of pi over 4 times the cosine of 5 pi over 6 plus, since we keep the operation, and then we switch. We get cosine of pi over 4 times the sine of 5 pi over 6. So the sine of pi over 4 is the square root of 2 over 2. 5 pi over 6 is in the second quadrant, so our cosine is going to be a negative rad 3 over 2. Now the cosine of pi over 4 is square root of 2 over 2. And again, 5 pi over 6 is in quadrant 2, so that will give us a positive sine value of 1/2. And when we multiply these, we get a negative square root of 6 over 4 plus square root of 2 over 4, which we can combine into negative square root of 6 plus the square root of 2 all over 4. Now with our second problem, with our tangent, notice it's not giving us one angle, it's actually giving us the right-hand side of that identity. Our top here is a difference, and remember that sign is the same. So we know that we have the difference of those two angles. Alpha is our 100, beta would be our 70. So this is equivalent to the tangent of 100 degrees minus 70 degrees, which would be the tangent of 30 degrees. And if you don't know that off the top of your head, remember tangent is sine divided by cosine. So the sine value of 30 degrees is 1/2. Cosine value of 30 degrees is rad 3 over 2. The 2's reduce. We get 1 over the square root of 3. And generally, we do like to rationalize the denominator. So if we multiply top and bottom by the square root of 3, we will get square root of 3 over 3 as our result. Now, in example 3, we are going to use sum and difference formulas, but we may have to find other information first. Suppose that A and B are angles in standard position such that the cosine of A equals negative 7 over 25, and A is between pi and 3 pi over 2. Well, that tells us we're in quadrant 3. We also get a value for sine. Sine of b is a -3/5, but b is between 3 pi over 2 and 2 pi. So this guy is in quadrant 4. That's okay. We want to find the exact value of tangent of alpha plus beta. Well, if this is what we are looking for, what is that formula? That means that we have to find the tangent of angle A and the tangent of angle B, and then we have 1 minus tangent of A times tangent of B. That is our formula for the sum. Well, in order to find the tangent of angle A and the tangent of angle B, we need to know either the opposite and adjacent side of both of those angles, or we need to find the sine and cosine and divide. So let's first focus on the fact that cosine of angle A equals a -7/25. Again, we can use right triangle trig, or we can use the Pythagorean theorem. If we are using the right triangle trig, that means we have the adjacent side and the hypotenuse of a triangle. Don't worry about the signs. Remember, we can always do the signs based on the quadrant. So here's angle A. Adjacent side is 7, hypotenuse is 25. So we're going to do 7 squared plus, we can do y squared equals 25 squared. So that gives us 49 plus y squared equals 625. Subtract 49 from both sides, and we get 576. We take the square root of 576. That's going to give us a y value of 24. But again, our A is in quadrant 3, so that means our y value is going to be negative. So you might want to write yourself a note there. It's negative because we are in quadrant 3. So we can put negative there, negative there. So this tells us that the tangent of angle A, which is opposite over adjacent, would be a -24 over a -7, which is a +24/7. So we have found the tangent of A. Now let's do the same thing with angle B. We know that the sine of angle B is a -3/5, and sine is opposite over hypotenuse. So if we create just any right triangle with an angle B, we know that the opposite side is -3 and the hypotenuse is 5. So we want to find this extra side here. So we can take -3 quantity squared plus x squared equals 5 squared. This looks like it's going to be a 3, 4, 5 triangle, but we're going to work it out just in case. So that gives us a 9 plus x squared equals 25. Subtract 9 from both sides. We get x squared equals 16. So x equals 4. Again, here we're in quadrant 4. And so we have to pay attention to our tangent value in quadrant 4. If we're looking at tangent of angle B, our cosine value is going to be positive. Our sine value is going to be negative. So that x is going to be a +4. So if we do opposite, -3 over adjacent 4, we get a -3/4. Well, let's plug all of those into our formula. But let me remind you once again, angle A is in quadrant 3. Okay, so that means we have a positive tangent. This angle here was in quadrant 4, which means we would have a negative tangent. So even if you didn't worry about it up front, think of it as sine over cosine, or y over x, y over x. So let's plug these in. Tangent A is 24/7 plus tangent B, which is a -3/4, divided by 1 minus tangent A, which is 24/7, times a -3/4. Now we can multiply everything at this point by the least common denominator, which would be 28. Multiply the top by 28. That means we also have to multiply the bottom by 28. So when we distribute, 7 goes into 28 4 times. So that gives us a 4 times 24. Minus 4 goes into 28 7 times. So that gives us a negative 3 times 7. 28 times 1 is 28. And notice that the 7 and the 4, if we were to multiply them on that second one, it would be 28. So that just leaves us with a positive 3 times 24. So if we simplify all of that, we get 75 over 100, or 3 over 4. In example 4, we're asked to find the exact value, but notice we have functions within a function. It's almost like a composite, right? For both of these, this is like angle alpha minus angle beta, because they are inverse functions, okay? So they are equal to angles. Well, we know what angle gives us a cosine value of 1/2. That would be pi over 3. So this is the same thing as the sine of pi over 3 minus, we're going to leave that sine inverse as beta because there's no angle that we're familiar with where we get exactly a 3/5. So that means we need to find what that value is. But let's first focus on sine of pi over 3 minus beta. If we were to plug that into our difference formula, we would get sine of pi over 3 times cosine of beta minus the cosine of pi over 3 times the sine of beta. Well, the sine of pi over 3 and the cosine of pi over 3, we know. Those are values that we're familiar with. Sine of pi over 3 is rad 3 over 2. Cosine of pi over 3 is 1/2. But we need to figure out what the cosine of beta and what the sine beta values are. That's where this comes in. The nice thing is this is saying that the sine of beta is 3/5. So we don't even need to know what beta is. We know that sine value already. So we can plug that in. Sine of beta over here is 3/5. But we don't know the cosine of beta. So we can use our right triangle trig or our Pythagorean theorem. Let's use the Pythagorean theorem this time, just to give us a little different, practice. So remember, Pythagorean theorem is sine squared beta plus cosine squared beta equals 1. So we get 3/5 squared plus cosine squared beta equals 1. This is 9/25 plus cosine squared beta equals 1. So if we subtract 9/25 from both sides, we end up getting 16/25. And when we take the square root, we get a cosine beta equals 4/5. When we multiply those together, let's see here, the 2 and the 4 reduce. And we would get 2 square root of 3 over 5 minus 3 over 10. So technically we could leave it that way, but we also may want to get common denominators. Oh, guess what? I'm going back where I started, putting that 2 back in that we reduced. So we get 4 square root of 3 over 10 minus 3 over 10, which gives us a 4 square root of 3 minus 3 over 10. And again, we cannot combine them because they're not like radicals. So this would be our final answer. In example 5, they're wanting us to verify the identity. Well, notice that the left-hand side is a difference, right? So we can use that formula again. Now, secant, remember, is the reciprocal of cosine. So we can write this side as 1 over the cosine of pi minus x. We can rewrite that using its difference identity. So cosine of pi times the cosine of x plus the sine of pi times the sine of x. Well, we know that the cosine of pi is -1 times the cosine of x, which we're not sure of. But the sine of pi is 0. So that gives us +0 times sine of x. So this whole thing here is 0. So that gives us 1 over a negative cosine of x, which is equivalent to the negative secant of x. And this is the same as our right-hand side. So we have verified. Notice I did not manipulate the right-hand side at all. We stayed with the left-hand side. Now there are cofunction identities that can also come in handy. And so the following identities hold for any angle theta for which the functions are defined. So if cosine of 90 degrees minus theta, that will equal sine of theta. Remember, cofunctions and complementary angles, they add up to 90. Cosine of 30 equals the sine of 60. So tangent of 90 minus theta would be the same thing as cosine of theta. Tangent of 90 minus theta is the same as cotangent of theta. Cotangent of 90 minus theta would be tangent theta. Secant of 90 minus theta would be cosecant of theta. And cosecant of 90 minus theta would be secant. And it also works not just with 90 degrees, but obviously with the radian equivalent, pi over 2. That is from this identity that we talked about earlier in a different section. Cofunction values of complementary angles are equal. So when they ask us to find one value of theta that satisfies this trigonometric equation, cosine of theta equals sine of 7 pi over 6, remember the function that we had, where sine of pi over 2 minus theta equals cosine of theta. Well, instead of pi over 2 minus theta, we have 7 pi over 6. Sine of 7 pi over 6 equals cosine of theta. Well, in order for both of these to be true, then this must equal this. So we would have pi over 2 minus theta equals 7 pi over 6. So we can multiply both sides by 6 if we want to get rid of the fraction. So 2 goes into 6 3 times, but that 6 is still going into that theta. So this would give us a 3 pi minus 6 theta equals 7 pi. Subtract 3 pi from both sides. That would give us 4 pi. Divide both sides by a -6. And we would get a theta of a -2 pi over 3. All right. Hope that helps, guys. That's it. See you soon. Bye.